Welcome back to my series for introducing DORM, Dry ORM. That is the project I'm working on. And the last time we talked about various ways of how we could iterate or interact with the individual elements of the table. But the problem is that the table is a generic construct in here. So we could add a couple of fields. And here's the problem, right? So let's say I would like to add a condition on the table. Let expensive items would be, product. Okay, so expensive items is a clone of this product set. For the added condition, it's amazing. We'll get the field. Now, there might be no field like that. So we'll have to put a question mark here. Say that this is greater than JSON. Okay, cool. There might be some errors here. Yeah. All right. So this is kind of the quirk of Rust. And I've been trying to figure it out, and I think I figured it out, but let me just show you. So when we're adding condition, you see the condition, the arguments for this add condition, the first argument is self, which means this is a method that consumes the table, and then it's yielding or generating another table which will have the condition. But while it's doing that, I cannot use self, or in this case, table, for anything else. Right? So this is kind of going to be no, that's actually a different one. It does work. Yeah, I'm not sure why it responds with fail. It should definitely respond with the option of fail, because maybe there are no field like that. Okay, fine. Yeah, this actually might work. Let's do some of the debugging. Print len pencil items preview. Nice. I like that. Where the price is more than that, although we could do probably less. Yeah, awesome. Amazing. All right. Cool. Yeah, so this is possible. Right, so what I don't like about that. So first of all, there are clones, and then I have to do like get field, so potentially I mistyped the field. This is not very nice. And the way around that is by actually creating another struct. In this case will be struct product set. Yes, and it will hold the table of Postgres. And we're also going to impl the product set new. Nice, and the AI has just populated the whole thing for us. So that's exactly the same as in here, right? So we no longer need to do that. Instead, we could do product set new, passing that. Cool, right? So we have product set. Let's hide this for now. Except that when we're querying that, we'll have to do product set table believe we should arrive at something very similar. Yeah, still works. Now, there are some benefits to this. First of all, we can generate, so this is some boilerplate code, and if it's a boilerplate code, we can generate it with macros. So it's not implemented yet, once again, but it could be something like dorm, whatever, and it's gonna look at the fields that we need to create, and for each field, it will generate a pubfn name, gives us the field. Suppose we need self get field name. Save table. Okay. Expected field found. Yeah. Yeah, we could clone that. Right, so we don't want to touch the existing fields, and we can either return a reference to them, which probably makes more sense, right? So if someone wants to use something with a name, we just return a reference. If they want, they'll clone it. Fn description is the same for the default price. Okay. Now, if we wanted to create an expensive item set, let's see how it would look like. That expensive items would be product set. Yeah. Now, the only problem here is that we need to create that condition. And the AI kind of tries to link it to this one, but technically this might not be there, right? So we might be just without. We only want to have expensive items, and then it becomes a little bit complicated. So there is a way around that. Let's do this. So expensive items is going to be that. Then we need a condition, which will be this. And then let expensive okay. And needs to be table. Right. So expensive items, it's a table. Now we can probably run that. Okay, what didn't work? Oh yeah. There's nothing like that. Cool. Yeah, so that works. We still get the same query. And this way we hiding away the actual implementation of product set into like a separate model, and then we're using that. In fact, let me just show you some of the files around here. So this is the product implementation from the test. Yeah. So it defines product set with table, exactly like we talked about. And even tries to implement some really weird things like map. Right? Okay, so that could be one useful pattern to do this. However, there is this problem, right? So we always need to think about how we're moving things around. Yeah, so we have Postgres, we need to pass it as a clone inside, and we might go in a different direction slightly. So we can declare Postgres as a static system-wide variable, and instead, it's difficult to explain, but let me show you the docs. Oh yeah, no, we can do this. Bakery. Yeah, so this is a separate example. This is implementation here. So it uses exactly that. And in order to implement the static variables in Rust, there is this concept of once. And here's how it works, right? So we define a static variable of a specific type of once lock, and we're saying that potentially it will become a Postgres. So initially it has no Postgres. And then it has this lazy initialization, right? So it's called method. And what it's going to do is it's going to get the value of Postgres. It will expect that the Postgres would have been initialized. And if it is initialized, it's going to clone it. Otherwise, it's just going to throw an exception. And in here, this is our new main method. So this is exactly as we had before. So we are arriving at the client. And then we're saying set Postgres to arc of box of the client, and we generate the Postgres. So we're creating this Postgres. We setting it as the value for this global variable Postgres. And we also have the method to access Postgres, but it's not going to give us the ownership of that. Instead, it's just going to automatically clone things. Right? So if in my previous example I had to do Postgres clone, now I would just have to call Postgres like this. You just give me the new reference of Postgres. And then the second realization is our implementation for the models. We don't have to feed in the Postgres because they probably already can anticipate that we will be working with the Postgres. Right? So if we have like multiple dataset models, some working with Postgres, some working with something else, that is fine. And once again, this is a very kind of, it can be used in multiple ways. I think I showed you one way. This is now another way. So here's the bakery, right? The bakery set contains a reference to that. And when initializing, so let's look at this part here first, right? So we're creating a new table. We're saying we're going to be using the table bakery, but instead of cloning Postgres explicitly from the value that's passed in as the argument, we can use this method, which we have imported, and it will give us the clone of Postgres, right? So it's a global variable. Also, there are some like necessary initialization in place. Actually, that initialization is async, so we'll have to wait for it. But yeah, it's kind of, it's all fine. Now, the next thing, I like saying word second. The next thing that I realized is that we don't have to create bakery set multiple times. Instead, we can create it once, and then whenever somebody's called bakery set new, instead of rebuilding it, we're just going to give a copy of this, right? So let's see how that looks. So we have a table, which is a static variable, but it's defined inside this scope here, right? So potentially cake will also have its own table static variable, but it has nothing to do with our variable. All right, and then here we're saying this is the lazy initializer that initializes the table, and then we're gonna return the table, but this will only be gonna be called once, right? So if we call it again, we will receive a reference to the table, right? So this, you see, it returns the reference, And this is exactly what we're going to be yielding out of this method. So if somebody calls bakery set with a method table, it's just going to return the table. And we no longer need self in here because it doesn't actually store anything that we will need. And that's why this becomes a static method. So when we're calling bakery set table, yeah, this is no longer needed, right? So I delete that. So I could do bakery set at a equals table, right? And this is perfectly fine. What, it doesn't like the position of that? Okay, fine. Anyway, so yeah, the table is a static method now, giving us the table, and it's also pretty efficient about the way how it's doing that. So when cloning, it's going to clone all the fields as well, and all the conditions. And the reason why, yeah, this cloning is happening here, right? That's amazing, right? So if we call bakery set new, it will do the cloning. Potentially cloning can be expensive on the bigger tables, but if you just do bakery set and table, it gives you reference to the table. So if you need to grab a field, it's much more efficient to get to the table and then take the field off that, because this is going to be a really efficient operation. And that also allows us to have name, profit margin, and other methods here static as well, because once we figure them out, we don't really need to recalculate them. So these can be really complicated. So it could be joins, subselects, all that, and now custom fields, whatever. But this portion is really, really lightweight. You see that? It might be complicated to understand. Right, so if we wanted to modify the bakery set, we would call new, and then we can call condition, for example here, saying that the profit margin needs to be greater than 10. But you see, we can now use the field, the static call to the field for the bakery set, and we're no longer having any issues with the ownership or passing the ownership. This is like really much better way of dealing with that. All right, so and you can copy that. This bakery set, it doesn't need to be a variable anymore. It's just static code. Bakery set, yeah. So it's probably much more preferred this way. So you have like a expensive or like profitable bakery set, like bakery with high profit margin. Okay. Yeah, so that's what I wanted to show you about this. What do you think, guys? I'm gonna record one other video because I wanted to talk about enriched entities. Yes. So right now the entity is pretty dumb, so that's like an arbitrary structure, which cannot do anything. But I wanted to talk about the way how entity can be enriched, but that's going to be in the next video.